The central limit theorem. The central limit theorem states that the sampling distribution of the mean approximates a normal distribution, with a mean equal to the population mean and a standard deviation equal to the population standard deviation divided by the square root of n, where n is the sample size. If the sample size n of the random samples is large, then we can use the central limit theorem, meaning the sampling distribution of the mean will always be normally distributed as long as the sample size is large enough. Thus, we have this comparison. Now, a random variable x is approximated by a normal distribution with a mean mu and a standard deviation sigma. And our standardized formula for this one to get the z-score is this one. Now, since we're talking about the sample means, so we can just substitute some values from here. No? So we're talking about x bar. This will be approximated, therefore, by the normal distribution with mean mu sub x bar and the standard deviation sigma x bar. So therefore, with this central limit theorem, mu sub x bar is equal to the population mean and sigma x bar is equal to the population standard deviation divided by the square root of the sample size n. Therefore, our formula now for our z will also change. Our x will become x bar, which is the sample mean, minus the population mean divided by our standard deviation divided by the square root of n. So this will be our formula for the central limit theorem. Now, how large should the sample size be? When n is greater than or equal to 30, the central limit theorem applies. The sampling distribution will approximately follow a normal distribution. When n is high, the standard deviation is low. There's not much spread in the sample's means because they are precise estimates of the population's mean. Generally, as sample size increases, the sample mean tends to be normally distributed around the population mean and its standard deviation also decreases. Okay, now let's discuss some applications of the central limit theorem. The average cost of per household of owning a brand new car is 5,000. So the population mean is 5,000. Suppose that we randomly selected 40 households, so n is 40. Determine that the probability of the sample mean for these 40 households is more than 5,350. Assume that the variable is normally distributed and the standard deviation is 1,230. So this is our population standard deviation. Now we're talking about the probability of a sample mean. So it involves sample mean. So we will use the central limit theorem for our z-score formula with our z-score formula of x minus mean over the standard deviation over the square root of n. So here we have the probability that the sample mean for this 40 household is more than, so the sample mean, so that's why we have x bar, that's the notation for the sample mean. So more than 5,350. Okay, using this formula, so this will become z greater than 5,350 minus 5,000 divided by 1,230, which is the standard deviation, divided by the square root of 40 because the n is 40. Using your calculator, you will get c greater than 1.80. So this is 8. Okay. Now take note, this is greater than, so our strategy tells us that we must have 1 minus the area to the left. It's because our table, or the table that we're using, is the area to the left. Okay, So we're asked to find the z is here 1.80 greater than, so we need this. Okay, so in order for us to get the area here, we will subtract this area. This is the probability of z less than 1.8 from 1. Okay, so that we can get this area. Again, our table is the area from the left, not from the middle. So that's why we have this strategy. So we have 1.8. Where is 1.8? So 1.80. So 9641. So 1 minus 0.9641, which is equal to 0.0359. Or if we convert that to percentage, 3.59%. So the probability that the sample mean for these 40 households is more than 5,350 is just 3.59%. It's very small. Another example, number 2, the average age of a car registered in the LTO is 10 years or 120 months. Assume the standard deviation is 20 months. If a random sample of 35 is selected, find the probability that the mean of their ages is between 115 and 129 months. So here we're talking about a random sample and the mean of this random sample. So we're talking about the sample mean. So we're asked to find the probability that the sample mean of these 35 cars is between 115 and 129. So we'll use the formula 115 minus the population mean. We will use months because 115 and 129 are in months. So we have 120 minus the standard deviation is 20. N is 35. There are 35 cars. So this will become now Z. So we have 129 minus 120 over 20 divided by square root of 35. So you can use your calculator. The answer for this one is negative 1.48 and the other one is 2.66. Okay, so since this is between, so our strategy is to have this P of z less than 2.66 minus the probability of z less than negative 1.48. So let's look at the table. 2.66. So we have 2.6 here. And then 6 is right here. So 6. So we have 9961. 9961. And the other one, negative 1.48, negative 1.48 is this, 694. Zero 0.0694. So the result is 0.9267 or 92.67%. So the probability that the mean ages of these 35 cars, that is between 115 and 129 months, is 92.67%, or it's very big. The chances is very big. Number 3, the average number of liters of fresh milk that a person consumes more than 16 liters per month is 18. So this is our mu. This is our mu. Okay, and the standard deviation is 4.5. Find the probability that a person selected at random consumes more than 16 liters. Now this time, if you notice, for this first question, letter A, we're not given with a sample, and we're not talking about the sample mean. So if this is the case, then we'll just use the basic or the regular formula for z-score. So more than 16. So this will become z equals 16 minus 18 over the standard deviation. Remember our first formula for the z-score, we have x minus mean over the standard deviation. But if we have now the sample mean, for the sample mean, the z-score is this one, over square root of n. Okay, so letter A, we're not talking about the sample mean or sample. So this is equivalent to or equal to negative 0.44. So where is this is greater than? So again, we have 1 minus pz less than negative 0.44. 1 minus 0.44 negative. So we have here 3300. So this is now 0.6700 or 67%. For letter B, now it gives us now a sample of 32. So n is 32 and we're talking about now the probability of the sample mean. So this time we will use the other formula for z. That is for the central limit theorem. So z greater than 16 minus 18 divided by standard deviation is 4.5 over square root of 32. So this is equal to 2.51. So negative 2.51. So this is greater than, so we have 1 minus p area to the left. Negative 2.51, 51. So we have here 0.006. So 1 minus 0.006. So we have 0.994. So for letter B, again, the probability is very high. So now let's go to number 4. A population has a mean of 75 and a standard deviation of 17.4. So this is our mu and this is our standard deviation. A sample of 35 items is randomly selected from this population. So this is n. What is the probability that the mean of this sample, this means that this is the sample mean, lies between 72 and 79. So since we're talking about the sample mean, so this is our notation. So x bar, so we have 72 and 79. So using the formula for z for the central limit theorem, so we have now 72 minus 75 over 17.4 divided by square root of 35. So this is z. We have now 79 minus 75 over 17.4 divided by square root of 35. So you will get negative 1.02 and the other side is 1.36. So this is between, so this will become or equal to p of z less than 1.36. So cross minus p of z less than negative 1.02. So 1.36, 1.3, this is 1.36 is here. 9131. So we have 0.9131. And the other one is negative 1.02, negative 1.02, 1539. 1539. So this is equal to 75.92, 0.7592, or 75.92%. So the probability is somewhat large because it's 0.7592. Number 5, an electronic company in Laguna manufactures resistors that have a common resistance of 120 ohms and a standard deviation of 13 ohms. Find the probability that a random sample of 40 resistors will have an average resistance greater than 114. So we're talking about, again, this sample mean of these 40 resistors. Average means mean. So we are asked to find the probability of the sample mean is greater than 114. So we have P, Z greater than, what is 11, the formula is 114 minus the mu, 120, divided by the standard deviation is 13 over square root of 40. And this is equal to P, Z greater than, this is negative 2.92. So since this is greater than, so our strategy is 1 minus P, Z less than negative 2.92. What is negative 2.92? Negative 2.92. 0018. So this is now 0.9982 or 99.82%. So in this problem, the probability that the sample mean of these 40 resistors is greater than 114 is 0.9982. Number 6, the same problem but less than 125. So P of X bar, or the sample mean, less than 125. P of Z less than 125 minus the population mean 120 over 13 square root of 40. So using your calculator, you will get C less than 2.43. So this is less than, so we'll go directly to our table. So 2.43. 9925. So the probability that the average resistance of these 40 resistors is 125 is 0.9925. Number 6, the mean serum cholesterol of a large population of overweight adults is 220 mg per dl. And the standard deviation is 16.3 mg per dl. So this is the mu, and this is the standard deviation. If a sample of 30 adults is selected, find the probability that the mean will be between 220 and 222 mg per dl. So we're talking about the sample mean. So we have this between. So X bar is here at the center between 220 and 222. So we have 220 minus 220 divided by 16.3 over square root of 30. So we have z, so 222 minus 220 over 16.3 over square root of 30. So obviously this is 0 because 220 minus 220 is 0. And the other one is 0.67. So this is between, so we have z less than 0.67 minus p z less than 0. So 0.67, so both of them are less than, so we'll go directly to the table. 0.67, 0.6, and then 7 is here. 7486. And then 0 is 0.5. So the final answer is 0.2486. So the probability that the mean of these 30 adults, that is between 220 to 222 mg per dl, is 0.2486. So it's somewhat low. Number 7, the average age of an accountant or of accountants is 43 years with a standard deviation of 5 years. If an accounting firm employs 30 accountants, find the probability that the average age group is greater than 44.2. So we're talking about the sample mean. So this is the, we will use the formula for the central limit. X bar greater than 44.2. Okay, we have 44.2 minus the mean. The mean is 43. Then divided by the standard deviation is 5. Then square root of 30 because there are 30 accountants. So using your calculator, you will get 1.31. So this is greater than, so this is 1 minus p z less than or equal to 1.31. So 1.3, 1.31, 90.49. So this is 0.0951, 0.0951 or 9.51%. So the probability that the average age group of these 30 accountants is 44.2 years, greater than 44.2 years old, is very small. So it's 0.951. Now, what is the probability of these 30 accountants? The mean of these 30 accountants, average age of these 30 accountants is below 45 years old. Okay, so the mean, we're talking about the mean. Below 45. Z less than 45 minus 43 over 5 divided by square root of 30. This is 5. 5. So this is now PZ 2.19 less than 2.19. So this is already less than, so we'll go directly to our table. 2.1, it's towards the end. 9857. Okay, so the probability that the average age group of these 30 accountants that is below 45 years old is 0.9857 or 98.57%. So again, if we are talking about the probability of the sample mean, so we will use this formula, the central limit formula for our z-score. But if we're not talking about a sample mean, just a pure probability, a randomly selected individual or thing. So we will just use the original formula for the z-score. Thank you for listening.